So, the medieval craft guilds are very often accused of rent-seeking, obstructing innovation, and preventing rather than sharing knowledge. And the recent research shows, however, that this is not necessarily true, and the situation strongly dependent on the craft and the city. So the situation is strongly dependent between the cities. And if we look very, very close enough, there are certain similarities we can find between how guilds used to operate back then and how software engineering industry works nowadays. After all, the subtitle of this classical book, From Journeyman to Master, cannot be coincidental. So one similarity that one might find is apprenticeship. I do have formal education in computer science, however, I'm not confident enough to say that it prepared me well for the job. Or, well, at least I do not remember attending classes that involved debugging a production issue. What's also interesting is that it takes roughly 3 to 7 years, depending on a company, to become a senior engineer, which is roughly the same time that the time that took to become a master of a craft. Also, craft guilds forbade innovation very strictly. However, that was barely enforceable. Well, poaching journeymen was a very common practice, and this way inventions traveled between cities and countries, and this is also what happens in our industry. And thanks to the conferences like this and the internet, it's even easier. So if there are certain similarities between guilds and our industry, maybe there's also something we could learn from the crafts. And I wanted to focus on one particular craft, which on one hand, just like programming, can be considered an art, or is considered an art, and on the other hand, had to satisfy customers' demands, painting. So if we moved back to 17th century Netherlands and looked at how painting's market looked like there, we would have seen that it was very, very interesting. Because the recent economic boom had caused a huge increase in middle-class population. There were also a lot of highly skilled painters, and this caused the works of art were in demand. And this huge demand had to be met somehow, and this called for optimization that would speed up the process of painting without compromising quality. So one such an optimization was specialization of painters. So for instance, this work was actually painted by 2 painters, Bartholomeus van Bassen, who specialized in painting interiors, and Esaias van de Velde, who specialized in painting people. Another optimization was using templates that we could compare to using frameworks that assuming we follow certain conventions, help us to build apps much, much quicker. Unfortunately, a lot of frameworks force us to tie it very carefully to them, and that's a decision that's very hard to revert back at a later time. Phoenix, the framework I assume majority of us is using here, it's not quite like that. Since version 1.3, with the introduction of contexts, it not only enables us, but encourages us to decouple the API layer from the actual business logic. But this seems not to be used properly quite often, unfortunately. So let me introduce you to one of the projects I had a chance to work with, and this is a dependency graph, module dependency graph of that project. So what we see here, this method of visualization is called hierarchical edge bundling. And what we do, we take all the modules from the project, we sort them by name, we draw them as an edges of the perimeter, and we draw an edge between 2 nodes if one module is aware of the existence of the other, either through a function call or a struct, or uses struct defined in the other one. And this project, although using Phoenix and contexts, faced 2 major problems. Well, first of all the data models, for some reason, have been taken out of the context and placed in a single directory. The second problem was that the contexts didn't seem to be split by a domain subdomain, business subdomain, but rather by single entity. So instead of having something like identity and access management, we had separate contexts for accounts and sessions. And this, unfortunately, leads to a very complex network of dependencies, something like that. And when we look at this graph, we don't really see any logical structure in this project, and yeah, that's a problem. And we kind of have an impression that every module could call every other module. So going back to painters, the ultimate invention, however, that sped up the process of painting back then was something else. It was an adoption of a new style, new technique. So prior to that change, painters paid a lot of detail into painting every single item on a picture with all the details. So even if the item was in the background. So for example, this work, also painted by Van de Velde. If you take a look at the birds in the background, the contours are really, really sharp. And what followed was something called painterly technique that encourages to focus on a picture, on the big picture rather than on its particular elements. So now if you take a look at the items in the background, you see they're not so sharp anymore, and like sky, it's even painted with heavy brush strokes. So let me introduce to you another project I had a chance to work with now, and hopefully this works a little bit more organized. This project also is using Phoenix and Absent, and in this case, all the modules related to controllers and resolvers live here. And I believe this proves that it is possible to create a Phoenix application that decouples APIs from the actual business logic. And the boundary is very clear, not just because I drew it in red. So let me remove the nodes, the edges going out from the API modules for a while, just focus on business logic. So on the right-hand side here, we can see a couple of modules that are very common to the whole project. They are called from a lot of modules, and these are related to these modules are basically like something like representing an error or money data type, common things. Well, maybe this suggests that should be extracted to external library actually. But besides that, we clearly see there are 6 tightly coupled groups of nodes, and these were actually what you see in red. These are actually contexts. And if your project looks like that, I'm saying you're using context properly because they're actually representing a business subdomain. And thanks to the really low number of connections cross contexts, if such a need arises, you can just take out one context, extract it from the project, and deploy it separately. But in that particular project, actually, we went one step further. And we also decided to decouple the whole business model from Ecto. And why would we want to do that? From Ecto and its persistence layer. And why would we want to do that? Well, first of all, different business objects have different persistence requirements. So, for example, we could store some business objects as S3 files, but also that separation allows us to think twice whether we need to persist a given object or not at all. And rather than going with the default behavior, which is to persist. So if we didn't model the business model, if we didn't model the business using Ecto, then you're probably wondering how did we do that? I'm going to demonstrate that. And let's imagine for a while we're building some loyalty app for art collectors, maybe, and we want to model a customer. So this is it. We're in the customer's context, as you can see from the module name, and then there's novelty that follows. This is model. So we're in the directory model, and the customer is a fairly simple struct. It has an ID which might not exist. There's a name that's a string, and there's a tier which is modeled by some other model. But what I wanted to focus on here is that we explicitly make the struct opaque. And this is because we want to encapsulate all the logic that touches this customer in this module. And dialyzer will help us with finding the cases when that's not the case. So the model also has a constructor. We take a map and try to build a new struct. Another advantage of opacity here is that if we ever have a customer model somewhere in the project, we can be sure that it had to go through this function. So we eliminate the situation when we're having a customer model, but it has invalid data from the business perspective inside. We also have an upgrade function. We want to update the tier of a customer to a new one, assuming that it's higher. What does it mean for a tier to be higher? We don't care about it here. This is the responsibility of the tier model. But what we do care about here is that we update the struct. And I want to stress that again. This module is the only place when we can do that. We also have a function called toMap, which responsibility is to convert the customer model into primitive types. And why we need to do that should be clear in a second. So if on our graph, in our dependency graph, we would just draw the models, the model modules in the project, that's what we get. We still see these common models here. But besides that, I believe the context boundaries are very clear now. And what is very, very important is that there are no cross-context links at all. And so what's also very important about models is that we do not do any side effects inside them. They need to be pure. So if they're pure, then you might be asking, how do you persist them then? Well, we introduced another layer, which is an infrastructure layer. We called it I/O just because the name stuck, but you can also find it under the name data access or DA in the literature. So how would it look like? The infrastructure layer is not only responsible for interaction with the database, everything that's external to us. Sending emails, push notifications, any other service that lives beyond the boundary of our system. So how did we do I/O for the customers here? Again, we're in the customer's context, then there's novelty I/O, so we already have model and I/O. And from the aliases, you can see here that the actual business model, customer model, is something different than the active schema we're using for persisting that data. Then we have a simple function called get. We get a customer for a given ID. And what's very important here, if you look at the spec, the contract is very clear. You pass models, you get back models. And the same applies for the update function. We pass models, we get back models. And from the perspective of the user of this update function here, the only thing we care about, here's the old customer, here's the new customer, please do update it. Which doesn't mean it is suboptimal and we need to update all the fields in the query. We can update only fields that changed, but this is the responsibility of this function here. This module is where this logic lives. So if we were to draw, not sure if that distinction is very clear, but the purple ones now are the I/O modules, blue are still models. You can see I/Os are also using errors, and there's one very commonly used module at the bottom. This is ectorepo. I guess we need to use that. Besides that, there's still no cross-context communication at all. And so to get the original graph I showed you before, there's only one thing missing here. That's something that we actually implement the business logic, all the business rule and all the use cases our system will provide. So we have model, we have I/O, and we have service. So our customer service, you see customer's context service, and we have an upgrade function. What's very different in this case is that we're no longer using models in spec. We need to rely on primitive data, because otherwise our model would leak out of the context. So what do we do in order to upgrade the customer? We construct a tier model, then we get a customer for a given ID, we upgrade the model, we persist it back, and if all that goes well, we return a customer, but not as a model, but as a primitive set of primitive types by calling toMap. So now if we draw it, we eventually get some cross-context links. And unfortunately, this kind of graph cannot show you the direction, the direction of the edges. But if we were to draw them in a more conventional way, we would have seen that there are no cycles here at all. And if we generalize it, there is a very specific relationship that holds between all these three layers I've shown you. There are no cycles here as well, and service knows about I/O and model. I/O knows only about model, and model only knows about itself. And we can also visualize this relationship using a pyramid, with service on top, I/O in the middle, and DA at the bottom. And the rule here is you can only call the modules at the same level or below. And since we already have a pyramid here, this resembles us another pyramid we know from the software engineering, namely the testing pyramid. And if we were to use the names or test levels as proposed by Google, this perfectly matches to testing use cases on the large level, testing external integration with one external dependency on the medium level, and testing our business model on the small level. And I'm pretty sure you have a lot of reservations about this approach. So let me just address three top frequently raised concerns. So first of all, this is not the Elixir way because it prohibits pattern matching and it looks like OOP basically. And I see it as a trade-off. Yes, we cannot pattern match on particular model fields, but what we get in exchange for that is all the logic related to the whole business, one business model is in one place. Second concern is that it actually involves much more code because we need to write a model and then ecto schema. And I like to compare it to something like reading a scientific paper, which is very compressed and has a lot of shortcuts, versus reading longer text that explains the same concepts in a more approachable way. And finally, the development is slower here, which is true, but usually just for a couple of weeks until everyone's on board with that. And I was thinking how to visualize it, and then just decided to use the graph from one of the recent Martin Fowler's blog posts. And basically the gist here is that the good internal structure of a project is paced out very quickly, and is the only thing that, after project reaches certain size, is the only thing that will allow us to introduce any changes. But what I personally like most about this approach is that it basically simplifies the whole code review process and also onboarding. Because if you want to check out what the system is doing, or what new features have been introduced, we just run the large tests, or check out the service modules. If you want to check out what external dependencies do we have, then we just run medium tests, or check out the I/O. And if we want to check out what the domain model is that we're dealing here with, we just run the small tests or read the models. And a bonus thing we did here, actually, we didn't only decouple our application from underlying frameworks, but from a whole technology, we could say, because we can use exactly the same thing not only in Elixir, but really everywhere else. And in fact, this approach or this style is nothing new. It has been invented quite a while ago, and you might have seen it under the name of clean architecture. Well, also domain-driven design is considered to be overcomplicated sometimes, but in its core, it's about splitting the subdomain properly and not allowing infrastructure concerns contaminate it. And finally, closer to our world, Scott Vlaschin, the author of F# for Fun and Profit website, covered this and much, much more in this book I strongly recommend. So just going back to so on this painting we have the Alchemist. So going back to the Alchemist painting from the first slide. I do not claim I covered all the possible cases here, or this is some sort of silver bullet for software engineering and will help you with every possible problem. Rather, I'm trying to show an Elixir approach to an Elixir take to what the grand masters of the craft are trying to teach us. And what surprised me the most when actually doing that is that it actually worked out. So I'm also not convincing you, not trying to convince you that you should go back to work tomorrow and rewrite everything from scratch using this or a similar approach. I'm just asking you, next time you have an opportunity, maybe you're starting something new, just try it out. But please be persistent with it. Don't give up after 2 weeks. And that moment will come after 3 or maybe 12 months when you need to go back to that code, and I bet you'll be just able to understand what it's doing. And finally, if you go back, if you will be able to understand that code, what it's doing, I hope that will be the very beginning of your programming golden age. Well, thank you. Yeah, cool. Sure.
We have time for one question. No, I had you before. You can have one. You did good last time, so.
Okay. Oh, a lot of pressure. So we're going through this process at Nested right now with Elixir, and part of the thing we're struggling with this is how to properly separate our layers. It seemed like what you were doing is using just an API module between your service layer and your infrastructure layer. Have you run into problems with that? Are you looking for another way of doing that? Have you experimented with any other way of separating your service layer from your infrastructure layer?
So I'm not sure if I got the whole question actually. Separating service from.
So when you have your models,
yes,
and you want to persist them and you want to update them or get a model back out, you have one API module for your infrastructure for that model, and then you pass models into that. You pass models into those API functions, and that module just handles all of your infrastructure stuff, right? It orchestrates all your infrastructure work. Have you run into any problems using that method? Have you felt that that module has become overcrowded? How have you dealt with
So this is also actually separated. It's not like we have the whole I/O happening in one module, right? So this works. This works. So I have customers context. Then there is I/O, which is kind of sub context or sub layer or layer, and then there is another part, right? So in one context, we could have a lot of I/O modules representing different things, and I especially. So if we decide to store customers through Ecto repo, that's one I/O. If we decide to use, I don't know, store invoices through S3, we have customers.io.invoices, although I don't think that invoices in that context make much sense. I'm not sure if that's the answer.
Kind of. If I could talk to you after.
Yeah. We have a lot of I/O modules in one context, basically. It's not like everything is one place.